Let's get started. Today, we have the one and only Vin Vashishta with us. Big thank you for coming, Vin. I am so stoked. You are,
Thanks for having me.
yeah, man, you're a predominant voice, as they like to say, in the machine learning world and data science world. And it's for a great reason. You share and you have all kinds of information. You're a wealth of knowledge that we can all learn from. And I feel like we are very, very lucky to have you on here for you to talk to us today about this whole, I mean, there's a few things that we're going to talk about, but the whole theme is going to be a path to production and monetizing machine learning. And I think that is so on the top of many people's minds right now. Like whether you be a data scientist or you're up a manager, you're the CTO, you're the CEO, it's like, how can we get the proper ROI from this machine learning project or just our data science team? What can we take from it and make sure that it's worth it? So I really love this theme that we're going to talk about today. I want to start how I normally start. And can you just give us a bit of background on how you got into tech, what you're doing like now? Give us a little bit of a bio on you real quick.
I was one of those unfortunate souls who caught the first wave of machine learning hype back in the 90s. So graduated from college expecting to get hired by Microsoft or somebody to do AI, and whoops, no one wanted to do AI. So I sort of wandered into tech, did more of a traditional sort of arc, and found out that I was really good at a lot of different roles and ended up basically working in every phase of the software development lifecycle. And so I bring that sort of traditional software development, waterfall and agile experience in. And then about 10 years ago, was working on some projects in gaming where I was able to get some data that nobody else had access to in the industry. Nobody else had access to data across casinos about player behavior. And so all of a sudden this opens up behavioral data, behavioral analytics, and really opened up the field to me. And I began to realize there was a way to start applying machine learning and basic data science to get insights. And over the last 10 years, I've had this journey of getting into data science, figuring at first it was finding out there was a field called data science. Back in 2010 and 2011, a few of us thought we had invented something that Google had figured out 5 years before it. And predominantly worked as, I guess, a unicorn data scientist for most of my career. A lot of what I'm going to talk about today is what got me into the strategy side. I'm still an applied data scientist. I still do applied machine learning. And at the same time, a lot of what I do as part of applied data science is what I'm going to be talking about that is strategy focused. And in a lot of cases, it takes that full life cycle data scientist to come in and explain the strategy and then show a few examples. And that's what I've been doing really for the last 10 years. And if I had to say what's my biggest contribution to the field, I'd say I've gotten companies to spend money on data science. And that's one of the biggest things that I've done over the last 10 years is just get pockets open and get people at the senior level to be sort of familiar with data science, machine learning, expect ROI, and start spending seriously and expecting actual return on investment from data science and machine learning.
So cool to hear. And just so everyone knows, I'm going to give your blog a shout out, the ML Rebellion. It's got a wealth of information. I'll put it into the chat in case anyone wants to have a read around. I think one thing that really struck me, and we talked about this before everyone jumped on, is that idea of, okay, a company is opening up their pockets, they're spending money on machine learning, but they want to see something in return, right? This is not a charity. And how can we get that out of it, I think, is something that today we really can explore, because it's really important for not only the data scientists to be able to talk to their manager about it and show why, like make the argument for why we need to build this model or why we need to use this for this particular use case, but then also for someone who's running a business. And so let's talk a bit about like just some key areas and key problems that you see when you work with companies that are, needing to monetize machine learning. Where do you see they fall flat? And then the follow-up question would be like, how can we fix that? But let's just start one by one,
Yeah, the biggest issue is that someone's gotten to the business early on with a 3-slide presentation. Slide 1 is digital transformation, machine learning, 5G, IoT, and all of these different buzzwords that sound wonderful. Slide 2 is a huge question mark. Slide 3 is profit. We will have margins increase. We will be better competitors in the field. We will enter new marketplaces. We will see margins increase and new revenue streams opened up. And the problem is slide 2 is a big question mark. And that's where the problem starts, is that businesses are interested in the technology, interested in and expect revenue and profits and ROI to come from it. But how do you get there? And a lot of times the answer is hire data scientists. And it's not the answer. So that's really the problem statement, is it is insufficient to just hire data scientists and then expect profits to show up. It doesn't work like that.
Mm. Yeah, and that's something that I've talked with many people about, like where they expect something to happen because the data scientist is going to know how to magically fix their problems. And then a few months on down the road, they say, what are we paying these guys for? What are they doing? How they're not doing anything except costing us more money because of all this infrastructure they're provisioning. They're doing all this. So as far as that question mark goes, then what can we dig into that a little bit more? It's like somebody usually from the higher ups is saying, oh, we need this digital transformation and we're going to do it with data science. So they hire some data scientists. The data scientists don't have direction. And then how can we fix that?
Typically, that's when I've gotten into a company. Every once in a while, I get to actually build the data science capabilities and the machine learning capabilities, but that's rare. Normally, I'm coming in and fixing something when an executive asks the question, what's the ROI of machine learning? And they get this answer. It's jazz hands. So they'll bring in someone and say, okay, what are we doing wrong? And it's not so much an issue of we're doing something wrong, because in a lot of cases, there's prototypes that are making it to production. And that's not a bad thing. You're going to see your first few wins, and that's going to get people on board throughout the entire business. But where it falls flat is it doesn't work in the way that users need it to. It doesn't work in the way that internal users need it to work. It doesn't provide insights in the right way at the right time. And so there's all of these issues that start surfacing once you have a few successes. And that's really what drives a company to start saying, we got to do something better than this. And where they usually start, and this isn't the best place to start, but at least it's a start, is the concept of path to production. They see impediments from getting a machine learning algorithm off a whiteboard and into production. And so that's the first area of focus. You hear the buzzwords MLOps all of the time, and that's important. But that's just one piece. And so when we talk about the path to production, usually not well understood that that's what's happening. It's more of a traditional software development type environment term. And so a company first has to understand why. And you got to get data scientists on board, because most data scientists and process and structure, it's hard to do. It's hard to see why that should fit, why it shouldn't be more free form, why it shouldn't be more open timelines and that sort of direction. And the biggest reason why for data scientists is because data scientists need a reproducible process that ends up building something. It ends up in tangible results. And once a data science team starts building that process and getting tools that enable that process to go forward faster, all of a sudden they see the ROI and their lives get a whole lot easier, especially around things like source control, data control, being able to do model reviews as a team, being able to hand projects off so that, I can do version 1, somebody else can do version 2. Somebody else can take a look at version 1 and say, this could use improvement. And without tools, there is a very, very hard time with that sort of collaboration ever happening. and with any sort of traceability and understanding how the model is really built, designed, how are we gathering data, how are we analyzing data, how are we fixing our data up front so that we don't end up with just garbage at the end of it, the GIGO. So
Yes.
that's really the justification from the data science side. From the business side, they need something to manage. Businesses hate it when they say, okay, can you do this? And data science team goes, they come back a month later and the data science team goes, they come back a month, that they don't have anything to manage. And that's very, very difficult. So a repeatable process, the data science lifecycle allows them to manage the process. And they can, whether it's an agile framework or something more tailored to the business, it fits into what they typically do. And an agile data science team is, it's so much faster, so much more effective. It's so much easier to be a data scientist on an agile team. And it also breaks up the data science roles into multiple employee sort of areas. And so you have a data scientist, you have an analyst who can work together. The analyst does a lot of the data wrangling and the initial exploratory piece of it, and works hand in hand with the data scientist to understand the data. The data scientist builds the model and sort of goes through that iteration of model selection, training test, model selection, training test, the improvement, optimization, sort of the reduction phase where you start out with a billion features and every data point possible going into the model, and you start saying, okay, I don't really need all that. And then the validation step. And this really then explains why we need machine learning engineers, why we need the whole MLOps side of it. And ML engineers do the architecture and design, they do development, they do more of a traditional QA, which I think is forgotten a lot in the data science and machine learning world. It has to work in production. It can't just work on our environment or in a Docker container. It's got to go out there and work. And then the integration piece, which is key, because machine learning models don't exist in a vacuum. They integrate into something else. And so that's a huge piece of MLOps is integration with existing systems, sometimes entirely rewriting algorithms in order for them to fit better into a production environment. You have maintenance, which rarely talked about. Models drift. Models stop working because, great example, I got phone calls in February this year, and pricing models at a particular client of mine stopped working. And that was what's going on here? And, March, obviously we found out why.
Yeah.
But if you don't have that maintenance and you don't have sort of that optimization and continuous improvement, until something catastrophic happens, you don't know it's coming. And in a lot of cases, your models can run for 6 months or a year. And no one realizes that there's a problem because no one's measuring. And so that's the long-winded answer to that's a path to production. And that's productization.
Totally. And I want to talk about like those day two operations in a bit. But before we jump into that, I think it's an interesting question to look at, like what you mentioned with the data scientist and creating that repeatable process and how we can go about that. Is that just using certain frameworks? Is that getting tools that will help you along? Or is that like a whole company-wide, you need to have everyone on board and you need to set up the actual process from everyone in the whole team and everything? What does that look like usually when you see it?
The right way to do it is to start with the strategy, the business strategy, the process of creating the strategy, the 1 year, the 3 year, the 5 year plan, strategy planning, competitive analysis, the whole traditional world of business strategy. It's where it should start. It doesn't. Companies will make every mistake possible. They'll do everything wrong before they decide to do something right. And that's where it should start. But like I said, it doesn't. I have to be a realist. It starts with the team. The data science team and the project management team, product management team around it, at some point come to the conclusion, this is not working. This could be better. This is painful. And it's that pain that drives. And where that goes is integrating data science and machine learning into other teams, beginning to bring outside stakeholders in who don't know what to complain about. They get machine learning products, they get dashboards, they get analytics, The response that they'll give is, well, that's nice, but it doesn't really work. There's the disconnect. That will typically bring together a large enough group with enough buy-in to start changing process. And that's kind of the external side. That's the business starting to manage the data science lifecycle. And you'll find internally from data scientists that this 50 tools, 8 libraries, some people using R, some people using Python, somebody's using Scala. Everybody's got a niche tool that they love and they know how to use, and only they know how to use it. There's no source control, there's no data versioning, and eventually everybody gets tired of it, especially as the team gets bigger. And data scientists get asked to do things that not really in their job. I mean, why do you want to pay somebody a ton of money to do data wrangling and spend 80% of their time doing data wrangling?
Yeah.
When they can be far more efficiently used really in that model development and iterative cycle. That's where machine learning becomes a team sport. Those are really the drivers.
Yeah, and you don't, all these data scientists aren't going to school and getting all these diplomas for data wrangling, right?
Yeah, exactly. I mean, data wrangling is important. Don't get me wrong. Data scientists have to do it, but it should not take that much of their time up. They should be looking at it more from it's already been analyzed, explored, cleaned up in some basic ways that every data set needs to be cleaned up. Additional data has been gathered. A lot of the missing data has been filled in or thought through. New ways of gathering data have been thought through. We've removed as much bias as possible. There's a lot of steps that come in early on that a data scientist should have input into, but that doesn't necessarily need to be the one who does it.
Yeah, and so looking at that, like this roadmap that you speak of, and road mapping from that beginning process to these day 2 operations, how can you successfully envision that whole thing?
Monetization is different than putting something in production. That's the key understanding. As soon as a company realizes monetizing data is different than just putting something into production, slamming machine learning in. If you ask about a data science roadmap or machine learning product roadmap, a company will point to a more traditional roadmap and say, no, it's in there. Everything can benefit from machine learning. No, you really shouldn't do everything. Machine learning doesn't do everything. Stop. You can do a lot of what you want to do using traditional development methodologies or basic analytics. What really has to happen, and this is where monetization and the concept of monetizing machine learning comes into play, you'll see companies start hiring research machine learning scientists or machine learning researchers. You begin to see a couple of titles around that, but the role is very much towards the front of the process. And it's very closely aligned, if you do it right, with strategy and strategy planning. And so the product roadmap, the ML product roadmap, is born from the business strategy, born from the 1, 3, and 5 year plan. The question that it starts with is, what products should the business use ML to build? What products should, not what products can. In a lot of businesses, the data science team drives the product creation instead of the strategy team driving the business needs. These are our problems. And if you come to the data science team with your problems, you begin to get better results. And this is where a researcher comes in. There is sort of this, here's our problem. And a researcher can start writing up a business case and saying, this is how this is a machine learning problem. And I think we should explore this further. The business can then say, okay, this is a product we want to pursue because you're solving a problem for us. And the first piece of monetization is reviewing the problem space. You've done a proposal. You've said this is a machine learning problem. Now prove it. Go through and explain how machine learning will solve this problem better than some alternative, some traditional software development methodology. And that's your first gate. That's your first piece of the proposal. And if you're in academia, this is sort of a familiar process. You create a proposal, you get funding, and you have gated reviews. And at each phase of your research, you're going back to a committee, they're reviewing it, and they're deciding, okay, we're going to green light the next step of this. We're going to give you additional funding. And in companies, this is a gated process. It's a product management process that's fairly well understood. And a product manager will green light a project. And now it's time to go look at the solution space. Can machine learning actually solve this problem? Do we have a technical solution? Do we have the ability to implement that solution? Is this something not only that can be done, but can be done by the business? And that's your second stage of research. And again, gated process. You do a review with the rest of the business and they decide, okay, we will green light the next phase. We believe in the presentation that you've done. Great. Here's some more money. Go to the next phase. And that's where your researcher starts looking at the data that's available. What does the business have? What does the business need to gather in order to successfully implement the model? That's, again, you start getting into data wrangling, but this is more understanding the approach and almost to the point of prototyping, where you justify your ROI, which is your problem space. What would solving this problem return to the business? How much is it worth? And when you start talking about the solution space and the available data, those are costs. What solution would we use, or what set of solutions? Because it's not normally one thing. You're going to have to explore multiple avenues in order to get a good solution. And it's now defined. This is how much it would cost. And potentially it's a range, because if your first model works, awesome, we saved a lot of money. But a lot of times the first model doesn't work. You go through multiple models, multiple iterations, you learn a lot through the process. And so now you have a cost range. This is how much it will cost with existing data. This is how much it will cost to gather more data. This is how much each one of the approaches could cost. And so we have a range. It could take us 1 month, it could take us 6 months. Now the business has a lot of tangible, sort of the more traditional metrics, a lot of tangible understanding of what's going to happen. And that's critical. That's monetization. Now you have an ROI. Here's what it's going to cost. Here's the potential return on investment. The business can now go and take this. The researcher can now give this to the machine learning team and the data science team and say, okay, here you go, build this. I've laid it out for you. Here's the data that needs to be analyzed and cleansed, and in a lot of cases gathered, and you're going to need to get with some other groups in order to gather it. Here's the business case, the functional requirements. Here's what it's going to integrate with. Here are the approaches that I've seen that I'm pretty sure will work. In some cases, these are based on research. They have not been implemented by the company before. That's why you need a machine learning researcher. They're doing sort of that PhD level work that goes into defining the solution at a very high level that in a lot of cases data scientists aren't ready for. You have your mid-level and junior level data scientists who can contribute and build models, but that research, that's a little outside of their capabilities at the very beginning of their career. And then that's how it works its way. That's how a product then that can be monetized works its way through the path to production.
That's such good information, man. I'm sitting here just thinking about how much, so many questions that I have to ask on so many different points that you said. And let's go at it one by one. I mean, firstly, if I'm a data scientist, which I know there's quite a few that are here with us that are data scientists, how can I play more of an active role in that? Because, right, I'm not just going to try and throw my machine learning into everything, but if I'm talking to my project manager and saying, hey, this would really be a great problem to fix with this model that I just read about, is that something that is just a no-no? Or how can I be more proactive in that instead of just getting, hey, we're going to try and do this now because this machine learning researcher has made the case for it? And does it need to be it doesn't need to be heavily researched all the time? Can you speak to those points a little bit?
Kind of starting with the last one first. No, definitely return to common sense. Everything does not need to be thoroughly researched. There are a whole lot of simple solutions. It's basically ML as analytics, and that's a key concept. Machine learning can be used to effectively create analytics that quickly return to the business. So there's sort of, answering the last question first. Does everything need to be thoroughly researched? To an extent, but not everything. Return to reason. When we start talking about a data scientist approaching a product manager, a data scientist approaching a different unit within the business, that's huge. Do it. Doesn't matter if you're wrong, just do it. The more time you spend as a data scientist, machine learning data scientist with another team, the better you're going to understand their pain. The more time you spend face deep in their data, the better you're going to understand their pain and what it takes to solve it, what they're going through versus what they understand they're going through. This is, when we talk about storytelling with data, this is perfect. You are, as a data scientist, able to use fairly basic visualization to help another organization understand their pain points a little bit better. They know it hurts, but they don't always know why it hurts. That's step one. And it doesn't require research in the academic standpoint. It requires research when it comes to looking through the data. And again, I say put your head in it for a few weeks. You'll feel their pain. So definitely talk to everyone. On the strategy side, be very, very careful. It is very easy to be over enthusiastic. And we as data scientists are over enthusiastic. We overcommit. I'm guilty of that too, but many data scientists overcommit. We can't solve every problem with machine learning, even if it is something that falls into our domain. Not necessarily something we should, even though we can do it. And so talking to strategy folks, talking to senior decision makers, you get past the VP level, you get to the executive VP, you get to the C-suite. Be careful. If you have not been in that space before, there are dragons. They're big and they fire you quick. You can get into a lot of trouble and get your whole team fired. And so be aware of your audience and feel them out. If you've never talked to senior executives before, talk to product managers. They can give you the lay of the land over the course of 3 to 6 months. They can bring you into meetings with duct tape over your mouth, and you can start understanding how decisions are really made at that top level. Once you've done that, though, once you get the lay of the land, definitely, the faster you can integrate yourself into the strategy world, even if you don't end up being the person who is on point, exposing the data science team to the C-suite and senior executives, senior decision makers, that relationship is gold when it comes to what I talk about with monetization.
Such good points. And I think one thing I also wanted to mention that you said for me that really struck a chord was the idea of having these, how did you put it? You were talking about gathering data. That's a cost, right? And having this flexi scale of costs so that you can go to someone and really present numbers and not just say like, hey, this model would work really cool in this use case, right? It's like, no, here's some hard numbers and you can make a better case for it. So I see there's a question in the chat from Gonzalo. He's saying, you mentioned that when executives ask about ROI of their machine learning, they hear crickets. I have the same experiences. Measuring the ROI will highly depend on the use case they'll use machine learning on. Have you figured out how to quickly estimate an order of magnitude when this question arises?
You don't want to do it quickly. Get the business used to doing this slow, doing this the way that they do every other product. Most businesses that are using machine learning in a mature way have done product development in a structured manner. They've measured ROI of products. Machine learning is no different. You will often get sort of pressured. I think is the right word. You will often get pressured into giving an immediate answer. This is why I say, if you're in the boardroom, in the C-suite, be ready. You have to be able to say no. That's the most important thing I do. When can you have this by? We all want to say, oh, next week. Give me about 30 days to take a look at it. Give me a couple of weeks to take a look at it. I'll come back to you with a better answer. they're used to hearing that. Even if you are pressed, they are used to hearing, let me get back to you. I do not have a solid answer for you yet. Take your time. Do everything you think you need to do in order to define the business case, and work with product managers, work with people who either touch the customer directly or are in the groups that your product will support. Get a real answer, get a real range that you can be held accountable for, because every time you miss a deadline, every time you are wrong about an estimate, you lose credibility. And it isn't just you, it's the entire data science team that loses credibility.
The entire data
and no
science
longer
community
gets invited to that meeting. When you stop getting invited to meetings, you're in trouble.
Yeah, completely. It's like I was mentioning before, you know, then people start looking around and saying, what are we paying these guys for?
Mm-hmm.
And that's not the look you want to have, right? So
Yes.
I was talking with John Splinder a while ago, and he's a VC for machine learning startups. And he made the point about how expensive it is to do machine learning as your core product, right? Like these startups it's a machine learning product that they're bringing out into the space. And he was saying how this is not only expensive because data scientists and software engineers are expensive, but also just because the idea of getting a model right and getting it out there and making it be your product is such a difficult goal. And I was wondering if you've seen any companies that have done that, where it's like their core product is machine learning and they've been able to do it well, or if it's been just mainly like you've seen a lot of people crash and burn.
Seen a lot of people crash and burn. I do product evaluations for VCs in the machine learning space. I've said yes to one. There is a massive failure rate. Even with
many,
founders who are, what was that?
Out of how many? You said yes to one out of rough estimate?
Maybe 20,
okay.
Plus or minus a few. I've done some informal evaluations, so I guess that number is higher, but I think 20 actually based a decision off of what I said. Right around 20 of them probably did. And one yes, one green light. Even technical founders, they don't commit. You have to believe in machine learning. You have to be a machine learning first company. You have to have a differentiation that's based on machine learning. In a lot of cases, you have to have data that you control, which is unique. That is a key driver. You have to have data that you control, not that you're getting from somebody else, that you are able to gather because of some aspect of the startup or the founding group or the machine learning engineers has created a unique data set. That's key. Algorithms rarely differentiate a startup to the point where someone else can't catch up. Well, the biggest differentiator is in data and unique data. And then from there, you start seeing algorithms, machine learning methods, because you can't patent math. It becomes complicated there to protect your IP when all you have is a model and somebody else's data. So it's really the access to data that defines and differentiates. That's why so few succeed. They have novel models. They are first to market. Some even are attempting to define new market segments. However, doing that, once you get profitable, it's easy to get bumped if all you have is a model.
Oh, wow. Such a good point. I love that. So I wanted to ask a bit about tooling and what you think about the tooling ecosystem right now, and if you feel like it's worth it. Are you more into open source? Are you a proponent, like you were mentioning, how it's kind of wild, wild west out there, you know? Yeah. Everybody's got, oh, I'm using R, I'm using Python, whatever. And so how do you see the tooling ecosystem right now, and how do you see it in a few years?
A few years is hard. I see everything going towards custom model development. This is where the majority of companies that have gotten past those early stages of prototyping, they're putting things into production, they're monetizing machine learning. Increasingly, they're moving away from import from models. They use that definitely for analytics. You will see TensorFlow all over analytics. But you see customized models that make it into production that become competitive advantages. I've seen them in every language. I've built models in Java, which I know I'm probably getting some stuff thrown at the screen right now for saying that.
Why do you say that?
I've angered the community. I've built them in Python and R. Don't hate me. I like any language that integrates easily with the existing framework. That's why I've written models in Java. And once you start walking down the custom model development road, it really doesn't matter. You're building APIs for data scientists. Who cares what they access it in? If you're building it to optimize hardware usage, you're building it to integrate with whatever framework you already have. I mean, I love Docker. It's all over the place. I love AWS and a lot of the services that are already pre-built into that ecosystem. I love all of those. That doesn't necessarily mean I'm married to them. So when you say which tools, you need something for source control. If you don't have source control in data versioning, you're in a lot of trouble. Which one you pick, doesn't really matter. What does the team already have? What is the dev team using? In a lot of cases, you already have institutional knowledge. So data scientists can quickly come up to speed by asking the team that's already in place, what are you using? And so many other development teams already have all the tools you need. There's going to be some sort of automated deployment. There's going to be some sort of scale up that needs to happen that you're not managing all the time. There's all these, and dev teams already have all this stuff. There are very few niche tools that a data scientist needs. The whole point really isn't to pick one, and I don't want to be a salesperson for anybody that I may have sold in the past or represented in the past, but pick tools that work and one per purpose. Don't pick two that do the same thing. Just pick one and really filter it down, find out what the best tool for the team is, and pick those. I have some preferences and recommendations myself, but they're biased. Yeah. And they won't really help you by just listening to me. So I'm not gonna pitch anybody. Well, although I probably should. Yeah. I'm probably gonna get a couple of emails that are angry. Why didn't you throw my name in, man?
Yeah, don't worry. If anybody wants his recommendations, they can contact you offline and you'll pitch them all you want, I imagine. But yes. I think you raise a good point. Pick one for each part of this puzzle. And with all of these different tools, there's so much overlap right now, you know, like if you're looking at, especially when you look at the machine learning pipeline, or you look at just the machine learning, what you want to put this out into production. So serving tools, or it's something that we talk quite a bit about in the community Slack. And so how do you balance that when a lot of these tools have a lot of like bleed and overlap? And so what does that look like?
The best tools handle one part of the life cycle very, very well. Things like Spark. That's why Spark is wonderful. It does a couple of things very, very, very well. And it integrates with an ecosystem of other tools that handle one more piece or make one more piece much easier very, very well. And so you have this concept of core tools, and you have this concept of supporting tools. Core tools, you'll see a lot of overlap. So pick one core tool. Even though you can have 3 core tools that, they do their own little thing a little bit better. But it's better to find a core tool and then find supporting tools within the ecosystem that are specific to your use case. What pipelines do you develop? How much do you trust the data that's coming from those pipelines? You need a security infrastructure there. So you need a tool that's actually going to look at the data, do a lot of the cleansing, which is another tool. You need a security tool, which will protect your database from adversarial data rolling in or just completely erroneous data. A lot of times services go down and you don't know they go down until you've done a week's worth of bad data pulls. And all of a sudden, Why isn't this working? So there's all of these tools in an ecosystem. And again, data version that helps with what I just brought up. You can roll back to an older version of the data that gets rid of the garbage. And so now you're talking about a source control tool. And these all layer on top of each other. But picking the core tools first, pick your core pipeline, your core automation for spinning up resources, your core GPU management, all of those types of things, or resource optimization. I'm sorry, I went a little too deep with that one. Pick your core tools, and then based on your specific needs, configure those tools and find supporting tools that help you bring in data better, that help you bring in data faster, that help you aggregate data into a central repository, that allow others in the business to access that data, allow you to do the analysis early on. And if you can automate analysis, automate as much of that as you can so that people aren't spending a ton of time doing repetitive tasks. Source control, and from there, the collaboration tools. Don't have 5 messengers. Please don't.
Yeah.
I don't want to be on 5 different messengers. I don't want 8 different email threads for the same thing. I don't want to be getting notifications for deployments from 3 different. Make it as simple as possible. One tool for one purpose. Communication, use a single tool, single source of communication, not just in the data science team, but with people to come to. You have to have a single point of contact or a single communication methodology. And that's a tool too. Don't have 8 or 9 different tools running around for communications. Don't have 3 tools for deployment. Don't do that. Deployment should be automated. One button push, done. It's out, it's training or it's testing, or you're doing validation with it. Don't have 3 ways to do that. Why would you do that to yourself? Don't have 3 different types of environments. Wait, come on, stop. Don't have 18 Docker containers. You do not need that many Docker containers. I know everybody has their favorite flavor of every operating system in existence and configurations that are custom. No, stop. Just agree on a basic set. And if you need to do customization, make sure you review the heck out of this. You don't end up with just this repository of garbage that I used this one time because it was cool.
That's such a good point, man. I appreciate you pointing that out. And I know there's a lot of questions popping up in the chat right now, so I'm going to get to your questions. We have Fabiana asking, have you stumbled across any organizations wanting to adopt AI without having the foundations, such as data? How have you dealt with that?
Yes, spreadsheets, manufacturing. This is manufacturing and supply chain. I've had to walk around factory floors and find spreadsheets because this one person has a spreadsheet that no one else has, and they use this spreadsheet plus their knowledge from being there for 25 years. And that's machine learning. That's where they start machine learning. You can't do it alone. The organization at the top has to be bought into it, but you also have to, as an individual, as a data scientist, be willing to get in and sit down with people. It's especially manufacturing. This is where I've seen it a lot. Data's in spreadsheets, text files. Oh, I've seen data in text files, not organized. You have to clean it in ways that
we don't need to talk about.
I've
it
seen
in ways.
And it's ground up. There's no other way to do it. Ground up, walking computer to computer, getting everything together, hiring analysts. That's the first phase. Get a bunch of analysts in, 3 or 4 of them, and everyone's walking around finding data and putting it into a central repository, deciding what that central repository is going to look like. And sometimes you don't really have a very well-established dev team. So you can have 3 or 4 different repositories. IT is keeping a repository that isn't connected to any development environment. It's just connected to people's PCs and backups, and data lives there. Data lives in these databases that no one knows exists, except for 3 people who work in an IT closet. That's the ground up, is walking around and finding where all your data is and creating a consensus on where we're going to put it, how we're going to format it, how are we going to gather it going forward, what are our strategic objectives for machine learning, and what will it take to just build a foundation. Before you hire a ton of data scientists, what is it going to take so that when a data scientist gets there, they have in place enough of a framework for them to start work, for them to start achieving just those basic small win prototypes.
Wow, that's a brilliant answer. Yeah. So Sumita's asking, I work for a company that relies heavily on human curation to select quality content. We use that and user behavior on our content to predict what new content people might like. But the human curators are terrified that quality will go down if we start using machine learning. It might, but how can we convince them that the risk, some false positives, would be worth the reward, scaling up to many users and much more content?
Teach them how bad the decision-making process is right now. Your users will get a whole lot less scared if you show them ways that they can improve. And eventually you show them enough improvements, enough tangible improvements. You say, if you do this, you will see an improvement. And I'm going to come back to you in a month and I'm going to show you that this works. Then you start contradicting their thinking. Once you've gotten that sort of trust that the data knows what it's talking about, the data is right. And in some cases that benefits from you sort of stroking their ego a little bit and saying, you know, this thing you've been saying to me, I've got the data. No, you're right. You're really right about this. You guys really know what you're talking about. But let me show you something. And you begin to challenge their thinking. You'll find there are two types of people in knowledge intensive, knowledge curated work. It's really dependent upon heuristics. You'll find people with adaptive thoughts and people who are sort of static. Adaptive thinkers can change the way they make decisions based on new evidence. Static thinkers can't. You can't fix a static thinker. There's nothing in the world you can present to them that will change their mind. And at that point, you have to go outside of that small group and sort of to management identify, these are the people that I can help. These are the people that I can't help. So let me work with the ones that I can. And if you would, start working on the ones that I'm not having success with.
Wow. Another great answer. We have Yo asking us, hi, Vin, what are the 3 biggest challenges you faced when monetizing the value of ML products? And how did you overcome them?
It really comes down to one, and it's trust. That's the biggest challenge. And everything else sort of stems from that. There are a lot of more specific challenges, buy-in, obviously that's trust, budget, trust, letting me sit down in the boardroom, trust, allowing me to speak in front of a CEO, trust. All of those require small wins. And we hear about this a lot. Small wins open doors. And being able to show tangible ROI, really following that monetization, building a path to production, proving that I have done something and I've done something for you. Look, money. If you can tie a couple of projects, and if you can tie a couple of projects to the bonus structure of senior leaders, because every senior leader has goals, and if they meet those targets, they get bonuses for it. A lot of times these can be 2, 3, 4 times their actual salary. If you tie projects to what executives bonus on, they'll let you watch their kids. They will trust you with everything. That's how you get in. And like I said, don't tell executives I said that. As soon as they know your game in the system, jig is up.
Oh my God, that is incredible. I love that. That is such a great answer again. And yeah, trust is a huge thing. Trust in your data, trust in your colleagues, trust in
Exactly.
every piece of the puzzle. And you put it very eloquently. And if somebody does do that and you can tell us about it later on in the Slack, I would love to hear it. So tell us later, hey, I was able to.
I can't. I have non-disclosures that take my breath away.
Oh, there you go.
I've gotten the shut up speech so much now that I could probably give the shut up speech.
Oh, nice.
Yeah, I'm pretty sure everyone on this chat knows what I'm talking about.
Yep. Yeah. So I've got Jet. I think he is ready to ask a question. I'll let you take it away from
Sorry, I was going to ask you a question every week. I hope you don't mind. Thank you. Love your hustly style and your focus on strategy and talking about value and things like that is bang on. And again, Demetrios is following me around, I think, because his topics align exactly what I'm doing. We're doing some cohort modeling around, putting numbers on value of features in the product, and the insights that came out of it were astonishing. Do you find people have no notion that you can measure value? They're all focused on measuring costs and things like that. How's that experience for you, and how do you deal with it? I'm guessing from your conversation that you've kind of nailed a lot of that, but don't you find the people around have no intuition or concept of how they can do it? And that's kind of ironic for data scientists.
When you talk about data scientists, if I use the letters ROI, I get hate mail. And I've done that before. I've posted, you have to have ROI, you have to be connected to business problems. I get hate mail. Data scientists hate it. Until you work in a big company or a data scientist that's come out of a role as an analyst, or that's come out of a role that's business facing, you'll find they have an intuition for ROI and a deep connection with creating value for the business. A lot of data scientists come straight out of academia, and it's a different paradigm. It's not a bad paradigm. Research, there's a concept that the Fed's walking around with, that business dynamism is reduced and has been reduced since the 1980s. And a lot of that is sort of this knowledge is no longer permeating into companies. A lot of that has to do with our marginalization of the contributions academia can have and pure research projects can have on a company. But even pure research projects, you can see in that monetization roadmap that I laid out, that's where you use your researchers. And that's where a gated process helps unstructured research connect with tangible business and ROI. And that's how, in a lot of cases, the data science team begins to just see it. They see better adoption. Their work, and a lot of burnout in data science is because a data scientist does a ton of stuff for 2 years at a company and never sees a thing, never really has any connection to the ROI, to the return, to profitability. And creating that structure, really everyone's happier. The business is happier with it, especially when you talk about revenue, cost savings. Businesses have already sort of crossed that bridge when it comes to machine learning, the cost savings bridge. When you create a new revenue stream, data scientists can say, I built a product that's making our company $22 million a year.
Mm-hmm.
That's satisfaction. When a CEO can talk to the board of directors or on their investment call and say, this year, our machine learning initiatives resulted in $130 million in cost savings and $17 million in new revenue. Next year, we project that we will continue maintain those cost savings, and we will increase our revenue from machine learning products by an additional $7 million.
Yeah.
Huge,
Yeah.
huge.
Yeah, being able to quantitatively speak about value. I mean, we're in a MLOps context here, but coming back to roots of continuous delivery, that quantitative understanding of value and stop caring about measuring velocity and development costs. You also spoke about, I think, less timeline-driven things, more open-ended earlier on. But yeah, coming back to basics of continuous delivery and those principles. I've enjoyed seeing some people in the company recently start to get these ideas and the pleasure of being able to articulate value, and it makes everything so much more clear. There's very much less political conversations, but it just focuses things in absolute transformation, I think, really at the heart of it.
And you see less resistance, you see greater adoption. When you prove there's value, other groups want in on it.
So many.
Cool, superb talk. Thank you. It was so nice as well that you didn't even allow tools on the table. Thank you.
Yeah, and so much information without even having to touch on that. I really would talk to you for another hour, Vin. We may have to try and schedule a round 2 because I didn't even get into half of my questions that I wanted to ask you, and this was just very valuable for me, and I know for everybody else. I want to just make sure everybody knows, if you're not following Vin already on LinkedIn, I highly recommend it. He gives all these knowledge bombs. He's dropping them every week, every day almost. And if you also are not checking out his blog, I linked to it in the chat in case you want to see it again. I'm going to link to it again. And the only last update that I have, tomorrow, we're having a workshop with the good folks at Kubernetes. So if you want to come and see a tool and see how it works, you can get some hands-on experience and bring your questions, and they will answer and let you play around with the tool. So thank you again, Vin, and thank you everybody for being here and listening. This has just been awesome. This has been
Thank you, everyone. Thank you for having me on.
truly amazing. I really appreciate it. And it's just so much that, like you said, Vin told me before, so everybody didn't hear it, but you have these moments where a week later, I'm going to probably think, oh my God, yeah, he said that. And now it makes total sense. So yeah, feel free to hit him up, DM him, and let him know that this has been very useful. All right. I'll let everybody go. Have a great day, night, wherever you are. And thanks again, Vin.
Thank you. Have a good day.